It's a beautiful day in the Sahara, and over the next couple days you can expect to see scattered showers, lush grass growing, and herds migrating across the region.
Now, that forecast might sound impossible today, but according to new research from the Max Planck Institute for Chemistry, it's happened before. Not once, not twice, but over and over again, repeatedly, over the last 8 million years. Their research suggests the Sahara Arabian Desert has gone through multiple humid periods, with rainfall drastically increasing.
During those periods, the region would have looked completely different. The Sahara would have had endless grasslands, countless lakes, and ecosystems with wildlife unlike anything we see today.
Which raises a question. How do we know any of this happened millions of years ago?
And to answer that, we need to go back in time into ancient cave networks.
Inside caves, water slowly drips from the ceiling, leaving behind tiny mineral deposits. Those layers of built-up deposit form things called speleothems, or more commonly called stalactites and stalagmites.
The water in the caves came from rainwater that carried chemical information about the climate, which means after evaporating, the raindrops left the information inside the layers.
Think of it like tree rings. Every year, a tree's trunk grows slightly larger, and because of that, tiny growth layers are added to the tree's trunk. In the rings, you can tell based off of how much the tree grew, if there was a drought, heavy rainfall, and the general climate, through how much a tree grew in just 1 year. Speleothems work the same way, just with tiny chemical water drops.
So as these formations grow, they slowly archive the pattern of rainfall across millions of years.
Researchers analyzed these speleothems from 7 caves in Saudi Arabia. Using isotopic analysis and radiometric dating on these cave formations, scientists were able to reconstruct rainfall patterns as far back as 8 million years ago.
And what they found wasn't a single shift, it was a pattern. During multiple humid periods, monsoon systems moved north into the region and left enough rainfall to completely transform the environment.
And what is now a desert became a landscape capable of supporting wildlife, plants, and entire ecosystems.
Today, the Sahara and Arabian deserts act as a major barrier between Africa and Eurasia. But during these wetter periods, that barrier may have been reduced or completely removed.
This allowed animals to migrate across the region, and most likely allowing early humans to do the same, which means these climate shifts may have played an important part of human history when we were traveling across continents.
Sadly, the northern hemisphere experiences gradual cooling, which alters global atmospheric circulation.
The altered circulation weakened the rainstorms and moved them southward, drastically reducing rain in the region, and eventually led to the dry conditions we see today. Luckily for us, this pattern helps scientists predict how our climate might shift in the future, potentially helping us mitigate climate change, because understanding the past is crucial to understanding the future. Today, the Sahara Arabian Desert sits as one of the driest climates on our planet, but hidden below the sand are ancient caves, forming a record of a different past.
A green past, filled with lush lands. But now the Sahara is one of the biggest desert systems on the planet, though maybe our descendants will be able to see it green once again.